The first thing I want to do with today, we're talking about triangles. We're starting a whole new unit. This will be the last unit that we cover before the end of the term. And so when we're looking at this, I want to make sure we do a little bit of job of going back to elementary school. Yes. And maybe touch a little bit more on triangles from middle school. And then we'll look at the two really big concepts for today's lesson. So we look at our objectives for today. They're very straightforward. The first thing you guys need to do, this is basically a review of elementary and middle school, and that is to basically classify triangles based on angles and side measures. Who can give me an example of what I mean by that? Christian.
Like an equilateral triangle.
Yes, an equilateral would be another example. An acute triangle. A what? Scalene, yeah. Hey, they're right there in the notes, right? So we know how to look forward, okay? And then the big two things we're going to be talking about right here, this is kind of the next big thing we'll talk about next, is the interior sum theorem and the exterior angle theorem. We're looking at that. And then, yes, Brandon, we will be doing a proof. This will be on the unit test, and that is to prove the exterior angle theorem. It's 4 lines, so I think you guys might be able to handle that.
Four lines.
Yeah, 4 lines, so I think you guys might be able to handle it. So that's our objectives for today. So let's go ahead and jump right into this. Hey guys, when we look at classifying triangles, we can classify them on 2 methods. We can classify them based on the length of sides and on the measures of the angles. Okay, so those are the 2 ways that we can classify a triangle. So guys, what is scaling? What does it mean to be scaling? Right? No congruent sides. That means that each one of my sides is different. I have 3 different sidelines. And that's pretty easy. All right, you guys have heard that term before, scaling? Hey, you might have forgotten that. Okay, what about isosceles? Ivan?
Only 2 equal sides.
Yeah, there's 2 equal sides.
We thought it has lengths.
There's 2 equal sides. And then what is equilateral? Yeah, guys, you can use your English skills here. So equilateral, equal meaning equal, lateral meaning sides. So we have equal sides. So all 3 sides are the same. Okay, that's pretty simple, isn't it? Okay. But now this time let's say look at their measures of the angles. What would make a triangle an acute triangle? 90. Actually less than 90.
Yeah, it has to be less than 90 degrees.
Has to be, how many have to be less than 90?
Like 45.
All 3 angles have to be less than 90. Okay? So all 3 angles.
Hey, aren't they supposed to be like 45 degrees or something?
No. All 3 angles are less than 90 degrees. So that would be an example of an acute triangle. All 3 angles have to be less than 90 degrees. What is an obtuse triangle?
All angles add to 180 degrees.
All of them are greater than 90?
No. They have to add up.
Yeah, okay. First of all, the interior measures of a triangle add up to what?
180.
180. So, alright, first of all, what's an obtuse angle? Greater than 90. Okay, so how many obtuse angles can a triangle have?
3.
Okay, so guys, I want you to stop and think about it for a minute. Before you guys respond, think about that mathematically. You guys just told me that all 3 angles add to 180, right? And you told me that an obtuse angle is an angle whose measure is greater than 90. Is it possible then for a triangle to have 3 obtuse angles? Why not?
Because they're times 3.
Okay, first of all, let's say they were all 90, right? What's 90 plus 90 plus 90?
Over 180.
270. Way more than 180. So how many obtuse angles? What's the maximum number of obtuse angles a triangle can have? Brandon. 2? What's 90 plus 90? 180. We still got to throw in a third angle. So it's 1. A triangle can have at most 1 obtuse angle. What is a right triangle? Well, that's what a right angle is, but what's a right triangle? Yes, and it's different from a left triangle.
90 degrees.
No, that's what an angle is. What's a right triangle?
45. 45.
Well, that would be an example of a right triangle. Well, guys, in general, what is a right triangle? There we go. Guys, all a right triangle is a triangle that has at least 1 right angle. Well, that's not what you said. It has to have at least 1 right angle.
Why do you make it so complicated?
I'm not. So you guys speak the exact truth. Okay? Now, guys, again, take part in this word right here, equiangular.
I'm guessing they're all going to be the same.
They're all going to be the same. Well, if the sum of the angles is 180, what does that make each angle?
60.
60 degrees. So, guys, an equiangular triangle is 160 degrees. So all 3 angles are going to be equal, and they're all going to be 60 degrees. By the way, an equiangular triangle is the same thing as an equilateral triangle.
Well, as long as there's
Okay, so guys, number 1. What type of triangle does that appear to be on number 1? Classified on both the length and or the measures of the angles. What does number 1 look like? What type of triangle? Obtuse, yes?
Yes.
Obtuse scaling. Obtuse scaling. We always put the angle measure and then the length. So obtuse scaling. What about number 2? Equilateral. Okay. We can go with equilateral.
one part of the little thing isn't even connected to the triangle.
And that happens. Especially if I'm making the diagram.
Yeah, that's true.
Okay, what about number 3?
That's a right.
That would be a right triangle. How do you know it's a right triangle?
90 degrees in it.
Yeah. How do you know it has 90 degrees?
So there's not.
Got the box.